Weather has been implicated as a contributing factor in the crash of Air France Flight 447 in the Atlantic last Monday. The plane was headed to Paris from Rio de Janeiro and went down in an area where big-time thunderstorms rumble on a daily basis, the Intertropical Convergence Zone, or ITCZ, which is an elongated area of low pressure where the northeast trade winds in the northern hemisphere and southeast trades of the southern meet, or converge. Anywhere persistent winds converge at the surface, there's lots of rising air and clouds, and with the warmth and moisture of the tropics, lots of thunderstorms as well. The average position of the ITCZ is easy to find on a map of average yearly rainfall. This is estimated from a satellite called the Tropical Rainfall Measuring Mission. The ribbons of green that you see across the tropical Atlantic and tropical Pacific mark the average position of the ITCZ. And on this color scale, green corresponds to more than 70 inches of rain per year. For comparison, we average about 40 inches of liquid here in Pennsylvania. To get a sense for what the ITCZ looks like on a daily basis, here's a satellite loop going back a week. And notice it's not a continuous band, it's more like a constantly changing ragged band or necklace of clouds and thunderstorms. As far as the Air France flight goes, here's a close-up of the area where the plane went down. South America is on the bottom left there. This is a couple hours after the crash. I've drawn the path of the plane. The thunderstorm system it flew into was too wide to go around. It also developed very rapidly. You can really see that if we zoom even further into this area and then colorize the clouds based on temperature, which correlates to how tall they are. This runs for 3 hours surrounding the crash. The line is the flight path. The plane was at 35,000 feet. Notice how fast the thunderstorms grew right in its way. The occasional purple pixels that you see show up inside the white indicate cloud tops above 55,000 feet. That's extreme by mid-latitude standards, but actually not all that exceptional in the tropics. And although the plane was probably in the thunderstorm complex for at least 10 minutes, that alone should not bring it down. Investigators are now focusing on the theory that external airspeed monitors that protrude from the wing or fuselage of the plane, called pitot tubes, iced over and gave faulty readings to the plane's computers. This would cause those computers or the pilots to change the speed in a potentially dangerous way. Too slow and the aircraft loses lift and could stall. Too fast and the plane would be subjected to increased structural stress, in this case made worse by the severe turbulence it was in. What we know for sure, it's seldom that just one thing brings a modern airliner down. In this case, weather was likely a factor, though how much is still in doubt. Fred is back with the extended forecast next.